Hello guys, welcome to Zip Code, and today you're with me, Guruleo Kininda, Senior Software Engineer. And today we are talking all things idempotency, and we want to use this mechanism to ensure safer retries on our web APIs and also prevent duplicate transactions from being processed. So without wasting any of your time, let's take a look at that. So this will be a Maven-based project. The language will be Java. The Spring Boot version will be 3.5.6, and always take the latest stable version, not the snapshots. Always latest stable. It will just be a version number like that. Then looking into the actual project metadata, you see the group is com.zipcode. The artifact is idempotency microservice. This is just a demo project for Spring Boot, and the packaging jar should suffice. It's not an issue. The Java version will be 17. And going on to the dependencies, we won't use a lot of dependencies here. I have DevTools. This is just for convenience when I make some changes and the code is already running. I don't need to manually restart the server. The application can just bounce upon saving those changes. And then Spring Web, obviously we'll be creating APIs, so we want to use the Spring Web dependency for that. Then Spring Data JPA, we will be persisting our data into a database table. I'll show you just now so that we're able to verify and validate that transactions have been previously triggered or requests have been previously triggered. And then we are using S2 database. I will show you this will be an in-memory DB. I'll show you how to set this one up quickly in your application properties. And then finally, we have liquid-based database migration. This will just create our database tables, and I will show you the configuration for this as well. So just to add, we have the repository in our GitHub / zipcode studio / idempotency microservice. There is a number of projects in this particular repository, so if you're interested in other projects such as AWS integrations, S3, RDS, SQS, SNS, or whatever the case might be, I do recommend you check zip code repositories and you will find a whole lot of projects that are already available. So let's proceed into our IDE and we can basically start working on our project. So this is how the project looks like. I'm just gonna start this project up and I will just do a demo for you in Postman quickly so that you can see the end goal of this particular API. Let's see. Okay, Lombok is trying to set up the configurations, but that's not an issue. So this is starting up. I am using H2, so nothing really stays after I shut down the service. It clears everything because it's an in-memory database. But now, okay, the application is started. Let's just jump into our Postman. This is the API. I'm using localhost 8080 / payment. And you see I already have some payload here. And if I run this particular payload to create this particular payment, it will go through and you see a 201 created and I get a response back with a reference. This particular reference, I pass it as a header variable and you will see this is an X request ID, and using the same request ID I can search for this particular payment. Let me just use the get payment over there. Let's send this get request and we get the same result as what we passed in over at the site. So with that, let's just quickly jump into uh, our code base, or just to showcase the actual idempotency in this particular call. If I try to resend this request, it's going to say status failed, message payment already processed. I'm just doing this so that you can actually see the idempotency implementation, but in your real world applicable scenarios, what you would want to do here is basically send back like the same status as if the request was initially triggered. So idempotency, the main purpose is that the state of the resource does not change based off of the retry of the request. So in this particular instance, just to showcase, idempotency is the same mechanism used in a GET API. So if we try to get the request multiple times, we still get the same result. So nothing changed because it's the same state of this particular resource. Similarly with a delete, similarly with an update, those API or HTTP method calls are idempotent by design. So they already implement an idempotency mechanism because they do not give you a different result unless the resource changes. So in this particular fashion, we are doing the same here. We are saying try to create this, and we are blocking a multiple payment creation because the reference or the request ID is still the same. So we're saying this request has already been processed, so you need to add a new request ID, which therefore will notify us that you are actually creating a new request or a new payment. So you see here I'm generating a GUID, and I'll copy this to clipboard, and I'm coming to my X request ID. I'm gonna pass in that, and when I send this request, I get a success because my request ID has changed and my reference is now new, but everything else is the same. So we basically regard this as a new transaction, even though the payload and the details in what you pass in the request payload is the same. The request ID or the reference is different, which means we are triggering a new request or a new transaction. And this is why we need to protect, especially in terms of payments. You don't want duplicate payments to be sent through. So it's better to block this particular behavior of multiple or duplicate requests being sent through. So we say failed, payment already processed, and we send that back to the consumer. And then they would know that, oh, okay, this transaction has already been processed. Let's move on to the next transaction that we have, or trigger a new one. So let's jump into the code quickly, and then I will run you down how you can implement all of this. So first things first, we will start on our application YAML. So you will see here the application name, Idempotency microservice. The data source, I'm using H2 database, keep that in mind. So it's JDBC H2 memory, and the database name is Idempotency. DB close delay, -1, so we don't want any delay. DB on close exit, that is false. Auto reconnect true mode Postgres, so we sort of want to use, mimic a Postgres database behavior, and the driver is our H2 driver. The username and password, these are just defaults, so it's not like these keys are being exposed, they're just defaults when using H2 database. The liquid base configuration, we enable that, and we also define the changelog file, which is in our resources db changelog, and this is the changelog master, and we also have a changelog init db that just defines our payments table. So this is our payments table. Just to show you this entity, it looks something like this one here. So go to payment entity, and you will see this is our entity table is payment, and we have all of these columns over there. So reference, amount, currency, from account to account, created at, and these should suffice for what we want to do. And then we have some DTOs over here. We have error DTO, which has a status, message, and the created at. And we also have the payments DTO with the reference, amount, currency, from account to account, and created at. So it's pretty much the same as our payment entity. Then with those defined now, what we need is our business logic. So we can jump into our payment service interface. You'll see we have two methods here, which is a create payment and a get payment by reference. So the create payment, obviously, it will just create the payment. The get payment by reference, we just retrieve the process payment by the reference that we passed in. So that will be the key or the header key that we defined here, X request ID, and we will then retrieve a payment if it exists. If it doesn't exist, then we can create a new one. If it does exist, then we block the entire transaction. So going to the implementation of that, let's just see how that looks like. You will see payment service implements iPayment service. We basically add a dependency here on iPayment repository. Just to go to the repository quickly, you will see it as the at repository, iPayment repository extends the JPA repository of payment, and the ID is long. And we have our payment find by reference, and we pass in the reference. That's the only one we have here. Everything else, we just use the boilerplate repository functions or JPA functions. And then that's the repository. Going back to our impl, you will see that we add the create payment, and the create payment takes in the payment DTO and the request reference. So in here, we then build our payment transaction, passing in the reference, the amount, currency from and to account, and the created date. And then we have a mapper over here calling the payment repository.save with our payment transaction, this guy over here. And we then map that into a payment DTO because that's what we need to return. Let's go to that mapper. So you'll see in the mapper, we check if payment is not null, and we build our payment DTO with those details. Otherwise, we return a null. And then you will see over here on create payment, we also catch any exception that might arise from us saving that particular transaction. And the payment request failed for the reference, and the message will then be the exception that was thrown at that. Otherwise, we return a null, and then you will see when we call this particular create payment, go back to the usage, and you'll see now create here, we check the payment response, we pass in the create, and we then send that created with that particular response. So obviously we need to add a check to say is this null or not. If it is null, then we need to properly respond to our clients. But let's go back to our service because that's what we are discussing. On the get payment by reference, we pass in the string reference. And in here, we go to our repository, find by reference, we get the payment. If the payment is not null, obviously we use our mapper to map this to a payment DTO, and we return that result back to the user. Otherwise, we return a null, and I've already defined the mapper on what happens in there. So let's quickly jump into our controller. And in our controller, you will see that there is a this is a REST controller, a request mapping / payment. Hence, we have our / payment here. And then we have a dependency injection on payment service. So this particular injection will basically be aware of the correct implementation to substitute for this particular interface. So it will plug in the payment service impl. And then once that is injected, we will then have our post mapping of create payment, and we take in a request header of X request ID as the request ID, and then we have a request body of payment DTO. And the first thing that we do is call the payment find by reference to check if in our database we've already processed this particular request ID, and if we have, then just send a error which says status failed, message payment already processed, created at current time, and we return a bad request, right? And hence we see a bad request over here when we try to send a request that has already been processed. Otherwise, what it does, if the request if the payment by reference has nothing, or if this DTO is null, then we say, okay, there's no transaction for this particular request ID. Therefore, let's create a payment, and we will then, once created, we then return to our consumer with the response or DTO to say this is created successfully. Hence, we see a 201. So if I go back, generate a new GUID, copy that, and then just add a new GUID here. And then come back here. Maybe let's say this will be like a 500 or whatever, and then send this through. And you will see now we'll get a reference, and amount is 500. The currency from account to account at the current time. So we get a 201 as per our response as expected here. Obviously, there are ways to improve this particular implementation, just to ensure that there is no failure at this particular point. So we need to make sure that our response is not null before we can essentially return the this particular created or a 201 success. Otherwise, there is a trick over here, guys, that I want to request you to do is, can you, or is it possible, if you can answer this in the comments down below, is it possible to move this validation into like an HTTP interceptor and validate the transactions as they come in the interceptor and block them at that level, and remove it from the actual create implementation over here? How would you go about doing that? Just share your thoughts on implementing the validation, idempotency validation in a interceptor. How would you go about doing that? And then continuing, we have the last API, which is the get mapping with a reference path parameter or path variable. So you see here we only pass in the reference, and we just check if that particular transaction exists or not. So if the response is not null, we return a 200 OK with the response body, which is the payment details. Otherwise, we just return a not found, and we say payment not found. So let's try this and see. So if I come back here and I go to the get payment, and I change that particular reference to like something that doesn't make any sense, and I send that through, and you see we have a 404 not found, and our status is not found, and thus payment not found, right? And that's about it for this particular implementation. You see that if the payment exists, we get a response back. Otherwise, it will have the 404 not found. And over here, we're able to create a payment. And if we retry it again, it essentially gives a forwarded bad request. And using this mechanism, we are able to prevent duplicate transaction or duplicate request from being sent through, thus preventing duplicate payments. And this is the end of our video. If you like the video, please do like and subscribe. Comment your thoughts. Also share the question that I just asked on this implementation over here. And until the next one, for now, cheers.